Welcome back, pre-algebra. We are in lesson 37, and we're going to start talking about equations, the answers and solutions in an equation. So for the most part, we have seen problems like this, where we can say 5 plus 2 is equal to 7, and we think of that more as a number sentence. It is, but it is also called something, called an equation. An equation just means that both sides of the equal sign have the same value. This side equals this side. So it's kind of a thought process. Instead of thinking of this as whatever this is, this is a blank. Instead of thinking it like this, we're going to start thinking of it like this is equal to this. So whatever is over here should be equal to whatever is over here. They should be the same value. And that is what makes this equal sign true, is that both of these sides balance one another. They are the same as one another. So picture, if you will, an old-timey, I don't know if you've ever seen one, it's like a scale. It's what they used to use a long, long time ago, where they had these little bowls on this little kind of like a teeter-totter, almost like a seesaw on a playground. And what they would do is they would put some stuff in this one, right? And there was like a little needle on the top attached to this little bar. And then they would put like some little weights, like little 1 pound, half pound, 2 pound weights in here. And whenever that needle would point straight up to the 0 that it was at the top, there'd be like a little bar here. And when it would point right up to the 0, they would count up these weights, and that would be whatever this weighed. That was before they had spring scales and digital scales and fancy things to actually, it was before they had electricity, right? That's what they had to use in order to see what something weighed. They had to have these measured out weights that would tell them what something weighed. So, and back in the Bible days, back in Jesus's day, what they would put here was coins, because the coins were supposed to all be made the same. So they would put like apples, or grapes or whatever over here, and then that coin, they would put that coin in here, and they would keep putting the coins in here until it balanced. And then that was the value of the item. If it was in shekels, or pennies or dimes, whatever that was equivalent, that's the weight. It went by weight. So maybe, it was in what we would consider pennies, and they would put that many pennies in there until it balanced out the weight of the apple. I don't know. But they used to use some type of coin or a weighted, measuring device, because they didn't have electricity, and they had to figure out what things weighed, just like a seesaw, where you've got one kid that's heavy on one side, one kid that's really light. You got to put more light kids on the other side in order to balance out the other kid, right? So it's the same thing. But this is kind of the same thing as well. We want to balance these two sides and make sure that this statement in the middle is true. And an equation is all about making sure that this is kept true. In fact, all of mathematics is seeking to prove that whatever the statement is kept true. Whether it's an inequality or an equation or some other type of statement, we are trying to verify our values. So let's do an example. Let's say I had 5 plus x is equal to 7. How would I find out? Well, we kind of know what x is because we just had it written up on the board. But how would we find out if we didn't know? Well, the first step is to look at the signs of what is on the side with the x. We want to get the x by itself so that we can say x equals and whatever it equals. So we know the value of x, right? So the thing to do is to subtract or add whatever the opposite value is of this thing that's with the x, this number that's with the x. And right here we have a positive 5. We know it's a positive 5 because it doesn't have a positive sign on it. I know that sounds kind of silly, but we typically don't write positive numbers that are the first term in an equation with the positive sign. We usually drop it because it's understood, just like the 7. It's understood that this is a positive 7. We don't have to put the sign on it. But we know for sure, if it has a negative sign on it, that it's negative, right? We never write a negative without the negative sign. So this has to be a positive. So the opposite of a positive 5 is going to be a negative 5. So I am going to subtract 5 from this side so that I can get the x all by itself. But here's the kicker. If I do that to this side, then this is not going to be equal to this anymore. These are not going to be balanced because I will have taken away from this side of the scale. So in order to keep this equal sign true, I'm going to take it away from this side also. So when I do that, this cancels out and becomes 0. I have x all by itself, and 7 minus 5 is 2. I can check and make sure that I have the right answer by filling it in where it was. The x here, I'm going to put the value for x in here and make sure that this is true. 5 plus 2 is 7. 7 equals 7. So now I know that I have a true statement, and that makes x equal 2 the correct solution for my equation. Let's try some practice problems. So I have x plus 4 is equal to 10, and this is 37.1. X plus 4 is equal to 10. All right, so right away, I need to figure out what x is added to 4 to give me 10. Well, x is a positive 4, so I'm going to do the opposite, which is subtract. And I'm going to subtract from both sides because of the golden rule of equations, which is whatever you do to one side, do to the other. And you always do that for equations, always, so that they remain balanced. So now I'm going to do the math. This would cancel out and become 0. So all I have left over here now is the x. I'm going to bring down my equal sign, and I'm going to do this math. 10 minus 4 is 6. Now I'm going to check my work. 6 plus 4, because I'm putting the 6 in where the x was, is equal to 10. 6 plus 4 is indeed 10, and 10 does equal 10. So I know that this is the right answer. And whenever you type these into the system, you don't have to type x equals. In fact, I just want you to type the number. Okay, just type in the number. That's all I want. Let's do another one. Let's do 37.2. And 37.2 says that x minus 4 is equal to 10. Well, how do we handle a minus sign, Miss Tracy? Because this would be a negative 4. We have to take the sign that is with the number. Whatever's in front of it, that's what sign it is. So because this is a negative 4, we're going to do the opposite. We're going to add 4, because everybody knows that negative 4 plus 4 is 0. And the whole point is to have x by itself. So we're going to do the same thing here. We're going to add 4 to this side to keep it balanced. We have to do the same thing to both sides. And that allows this to cancel out and bring x down by itself. And then we add 4 to 10, x is equal to 14. Then we check our work. 14 minus 4 is equal to 10. 14 minus 4 is 10, and 10 does equal 10. So therefore, 14 is the correct answer. And guess what? That is all we have for lesson 37. I will see you in lesson 38.